Thank you, everyone, for joining us to this second presentation of the Learning Tokens LFDT Mentorship 2025. We've had a previous one. This is the near to the end, and we'll have a third one at the beginning of December. So I give the floor to Ankita. You're going to do the first slides.
Hi everyone, I welcome all of you on behalf of my team and thank you for taking the time to join us all today. We're really excited to share our presentation with you and appreciate your interest and support. So let's begin uh, with the introduction of our mentees and mentors. Next slide, please. So these are our fellow mentees, Vaibhav, myself, Ankita, Aviral, Harsh, and Hariom. Next slide. These are our mentors, Alfonso, Naomi, Harsh, and Raju. Next slide. So let's begin with what is the purpose of this project. So this project revolves around preparing for the future of work in an AI-driven world. AI and automation are transforming industries. While some jobs are being displaced, entirely new ones are being created. This creates a paradox. Technology replaces talent, but also demands new kinds of talent. Our goal is to help balance this shift through reskilling and resilient talent acquisition, preparing people for roles that might not even exist yet. Online education has become a powerful democratizer of learning, giving access to anyone, anywhere. However, it still struggles with low completion rates and limited motivation for learners to certify their progress. That's where learning tokens come in, offering granular, verifiable proof of learning and lifelong skill profiles aligned with job competencies integrated seamlessly into existing education system. So this mentorship 2025 aims to enhance current LMS platforms using non-invasive privacy-preserving connectors that link learner achievements directly to learning tokens, building a more transparent and motivating learning ecosystem. Next slide, please. So this diagram shows how the learning token ecosystem links instructors and learners through verified skill exchange. The instructor skill wallet stores teaching achievements, while the learner skill wallet records learning outcomes, the attendance, and the scores. At the center, the learning tokens acts as a bridge. Skills are transmitted by the instructor, accessed and approved, then acquired by the learner as verified tokens. This process creates a secure, transparent record of skill transfer between both sides. Next slide. Now, this diagram shows how learning is verified at two levels, overall and granular. In the overall flow, lessons progress through content and assessment, leading to a final certificate for course completion. In the granular flow, each lesson generates a learning token through a scoring guide, recording every proven skill. These tokens build a skill wallet, giving learners a detailed, verifiable skill profile. In short, the overall layer certifies completion, while the granular layer captures precise lifelong learning achievements. Thank you. Now, Weber will continue the next slide.
Hello everyone. Let me quickly walk you through the learning tokens architecture and how everything flows. The main idea is simple. We recognize student achievements, build their skill profiles, and make everything verifiable across platforms. We have two main parts. The key components on the left, like issuing platform, assignment engine, and verification system. And the technical components, registry, oracles, wallets, and smart contracts. It starts with course creation, detects events from LMS platforms like Google Classroom and Canvas, normalizes the data, validates it, executes smart contracts, records it on blockchain, and finally students gets verified in their wallets that prove their achievement. So basically, when a student completes something, it automatically flows through this pipeline and they end up with a blockchain verified learning token. Next slide, please.
So, hello everyone. Let's start with a quick recap of where we began. In our first meetup, we analyzed the LMS landscape covering open source platforms like Moodle, Canvas, Google Classroom, and OpenEDX, as well as proprietary ones like Coursera and Udemy. We found that while most LMS provide REST APIs, their API formats, authentication, and tech stacks vary, which makes integration inconsistent. Canvas, Moodle, Google Classroom, OpenEDX are the most developer friendly, while Coursera and Udemy have limited access. We have also identified some barriers: API inconsistency, scalability, privacy concerns, and UX complexity. To solve this, we proposed a unified middleware architecture that normalizes LMS events and communicates with blockchain Oracle. Next slide, please. So, what we did to come up with the barriers and to move forward with learning tokens is we built an SDK, a unified layer that connects with multiple LMS and provides normalized data. Essentially, instead of every LMS having a different API for things like courses, enrollments, grades, our SDK provides an and consistent structure. This means developers or partners won't have to handle API variations manually anymore. Next slide.
Hello everyone. Now I will quickly explain the end-to-end flow of learning token generation, how our system actually works behind the scenes. First, the institution and instructor register on the system. They upload courses to the different LMS platform, Moodle, edX, and all those, and connect them with our learning token setup. Next, learner register and get their own digital wallet, and where the learning token will be stored. When a learner takes a lesson or a quiz, the system calculates the score, and the score is often sent to the instructor itself. Next slide, please. Yeah. When finally, based on the performance, the system generates learning tokens and transfer them to the learner's wallet. So each token represents a student's verified learning achievement. In short, this flow connects institutions, instructor, learners to create a transparent and fair way to reward real learning. Next slide. as as you can see on the top itself, the different guys like the institution, learners, and the instructor, also the different platforms also they can use to monitor all these things. Thank you. The next tab is you. Ankita, you can continue now.
So now I'll be taking you through the OpenEDX as an example. This is what an experience used to look like for developers and instructors. Multiple endpoints like courses, grades, enrollments, and instructors all require different authentication, different response format, and a lot of manual effort to combine data. As a result, integration was manual, time consuming, and hard to maintain. Next slide, please. Now, this is the result after applying our integration. We are fetching and displaying data directly from OpenEDX through our SDK, unified and structured. You can see consistent data across courses, enrollment, instructors, and grades, all formatted under the same schema. This shows that a normalization layer works and can handle data mapping efficiently across platforms. Next slide. Weber, your mic.
Yeah, sorry for that. Another enhancement we have worked on is making assignment tracking easier in Google Classroom. When teachers want to see the full story of a student's assignment, like when they created it, turned it in, got graded, and received it back, they need to pull information from different places in the Google Classroom's API. The API works great, but you have to make a few separate calls and then put the pieces together yourself. We created a dashboard that brings all the information together in one place. Now teachers can see the entire journey of an assignment. When the students get started, when they submitted it, when it was graded, when it was returned. Everything shows up with timestamps and who did it in a single view. Yeah, next slide please.
I will walk you through the how we transformed the traditional Moodle platform into a something smarter, more transparent, and performance-driven using learning tokens. Here is where it begins. The Moodle learning token dashboard, the student enroll into their regular courses, but not every quiz, performance, score, and improvement is linked to the tokenized learning data. For example, you can see here, Soham and I both are uh, both are the student. Each quiz attempt is recorded in real time, and our performance is directly tied to the tokens. But these tokens aren't just numbers, they are a proof of learning, verified and securely stored using metadata. The metadata captures where, when, and how each activity happened, making academics performance transparent, traceable, and rewardable. This helps both teachers and learners clearly see the progress and identifies areas to improve for the learner and the instructor as well. Next slide, please. Now, this is how we integrated it with the Moodle main data system. Every student, every course, and every quiz result in synced directly with their learning token profile. Here we can see details like enrolled students, their email IDs, and the last login times as well. All those are mapped to their learning records. These connections turn normal LMS data into personalized learning economy, where every bit of process is measurable and meaningful. So now, when a student performs well, their achievement is not just shown as a score, it's stored as a digital learning token that represents verifiable growth. In short, we turned Moodle platform from learning management system into learning value system. It doesn't just track what students do, it reward them how they grow. Our system makes learning measurable, meaningful, and motivating, helping students to see real value in every effort they make. Thank you. Ankita, you can continue.
So now I'll walk you through a demo on how I integrated Canvas LMS with a custom JavaScript backend to extract and display all the instructors' dashboard data in one place using their API endpoints and the instructor's access token. So the goal was to automate data collection from multiple Canvas endpoints such as courses, assignments, submission, and grades, and present them neatly in a single interface. So instructors don't need to jump across multiple pages. So I'll quickly share my screen to show you the demo. Is it visible?
Okay.
I
Are you
can't.
sharing? Ah,
Okay.
thank
I
you.
don't see anything.
Okay, it's
Now,
visible.
okay. So as you can see, this is the Canvas instructor dashboard. Normally, instructor has to manually open each course and navigate through the assignment, the grades, and the announcements separately, which is very time consuming. So I wanted to make this process easier by connecting directly to their API, which allows us to fetch all this information just by running our code. So to access this data securely, we used the instructor's access token. This token acts like a secure password that authorizes the API to fetch data for that instructor's account. So in the setting of Canvas LMS, every instructor can find their access token. And using this token, we can fetch all the data with our code like this. As you can see, all the details are available in JSON format. And if it is represented in a tabular format, it will look like this. All the courses, assignments, the students, files, quizzes, and the grades. Thank you. Now Harsh will continue to the next slide.
Okay, so hi everyone, I'm Hosh. First of all, I would like to thank my fellow mentees for their research and development work related to specific LMS, APIs, and data collection. On top of which we have built our SDK, aka LMS Learning Connector. So now you would say why we need unified LMS connector. So, and I would say the problem that we have is isolated learning ecosystem that we have now.
Yes.
So the problem is the current landscape looks like something like this. We have a individual and different LMS, and then for them we have a different APIs. All APIs have different data structures. So this leads to inefficiency and very complexity in while we access these data at any point of time. So this is where our LMS connector comes in. Let's see how how we standardized all these workflow across all LMS through our LMS connector. You can see here, this is the full architecture that we have made for the LMS connector. So we have first component as the interface layer. Secondly, we have the overall SDK layer in which we have. So here we can see like the SDK. Let's say our SDK has a client layer and then server layer. So the client layer talks with the server layer and queries the courses to fetch the courses from the LMSs. Then the SDK Node.js server asks every particular proxy server to fetch the raw data from these LMS. These raw data are very unstructured data for each individual LMS. So for that, the connector sends this data to the adapter, you can see, for normalization. Then this normalized data comes back to the SDK server. This SDK server sends the client and renders the data on the interface, through which the instructor can easily and very efficiently see and cross-check all the data from any LMS if he wants. This provides the instructor very easy to understand way of um, uh, checking all the data that is coming from LMS. Let's say example, we have the here example of Canvas. We have the front end from where the instructor manages all the courses and cross-check all the details of every courses in any LMS. He manages course as he sends a query to SDK to fetch the any course data in Canvas. Then SDK servers reroutes and then fetches sends uh, this particular query to the connector. The connector sends this to API server from where the from API server of the Canvas. Then Canvas gives the data to the connector, that is raw data. Then the raw data that is there with the connector, it is sent to the adapter, which normalizes all the data and structures it. Then this structured data is rendered on the front end, and we can see a very efficient and consistent data format. Now let's see the demo, the live demo of the LMS connector that we have built using our SDK. So here is the dashboard of the LMS connector. You all can see this dashboard.
Yes,
Yes,
Harsh.
sir.
Okay, great. So here, if you see, we have multiple LMS. We have 4 LMS. We are using 4 LMS: EDX, LMS, Google Classroom, and Moodle. For these are the data that we are fetching. If you can see, we are fetching the course data, instructor information. For currently, for all LMS, we are not able to fetch the instructor data because of some permission scope. Assignment details, submission information, and discussion chats. So let's take an example of EDX. We'll move to the EDX and we'll see how the data is rendered here. We can see one course listed on the EDX LMS that we are fetching. Here is the course. We will manage the course. In here, this is the course page. We have multiple blocks that represent multiple information source. Course block, we have course information, then instructor. Unfortunately, we don't have instructor now. Then student assignment review. We have course information in which we have description, course number, and all. We don't have instructor here. Next, we have students, in which we are representing students and their email information, enroll date, and all. Then we have the most important block of this data, which is assessment block, that has multiple quizzes and courses, and we have the ID particular to these assessments, and then their corresponding marks, what they have got, the each students that they have got. Next is the review and confirmation. Here the instructor reviews all the data once again, and then it reviews all the course statistics, and then it gives the consent to move forward for the learning tokens assignment. Yeah. So the sixth step is the assigning learning tokens. From this particular page, he will be redirected. Once confirmed, he will be redirected to the learning tokens dashboard. We have also the JSON and PDF data that we have made for easy to access for a instructor. This is the tabular version that he or she can download and review all the data uh, once the token is assigned and all. This is the tabular data. We have also the JSON format. This is the JSON format. You can see here. Yes. So we have the course data, and then we don't have the instructor data for now. We have assignment particular to all the learners, assessment data, and all. Okay. Now, as we seen for the EDX, we can see for all the LMS in this way. Let's say we have the Canvas LMS. So in the Canvas LMS, we have one course, and for the same way we have been fetching the data for EDX. We have the data for Canvas as well. You can see assignment details and everything. And then once it is reviewed and consent, then the instructor will be redirected to the learning tokens dashboard, where he will assign all the tokens to the every particular student in the particular LMS. So thank you for your time to review the demo. And then now our fellow mentees will tell you what is our next goal that we are going to work on. Thank you.
So as you saw, like we have completed our SDK and we'll be giving to you like very soon. Now the next step is that we'll be making an npm package from our SDK, and we'll then move forward to integrate it with learning tokens.
Then we plan on integrating this learning token backend with our current SDK.
We'll also add a feature to verify the skill wallet and the tokens achieved.
And also the next mentorship, what we will be doing is we will be adding AI to make the system even smarter. AI will track how students learn and improve over time. It will make token rewarding, fair, and personalized for everyone. With this, the LMS platform won't just manage learning; they will recognize efforts like reward growth and also redefine also they will be redefining the education itself. Yeah. Slide.
Okay, so as we have presented our work, all the work that we have done till now, now that we want from all the participants the call to action. What we are doing, that is a important work. So we want help from all of you to help us build our ecosystem of affordable, modular, and granular open source software components that cultivate talent, improve teaching, increase trust, and put together a better learning experience in the world. Thank you. Now these
Thank
are
you,
the
Harsh.
yeah, these are the
Go ahead.
references that we have that will be shared after the meet all from for all the participants.
Thank you, Harsh, and thank you all, Abidal, Ankita, Hariam, Vaibhav, and Noemi also as a mentor. We open now to Q&A. You can write your Q&As in the chat, or you can take the microphone, as you please. There's a question in the chat asking for the SDK, and I had answered saying that we shall publish the SDK by the end of the mentorship next November. And the question is, just to clarify, do you mean November 2025 or November 2026? It's November 2025. Okay. The mentorship goes from June to November. And we'll have another virtual meetup at the beginning of December to show the complete package that we explained today. Are there any other questions? Interest?
Yes, there is one from Daniel. He asks, what kind of buy-in do you have from platforms like EDX and Coursera to implement the learning tokens framework?
Not yet. Not yet. We want to complete what we're doing. And once we have it, then we'll approach those platforms. That's the idea, exactly. We are at the moment, we are ready for pilots. And we're working on 2 pilots, one in Mexico and one in El Salvador. Okay. And we're open to any pilot that you would like to do with us. Thank you for your good wishes, Anasuya. We also have a pilot pending with Beanie World. Okay, we haven't forgotten. We're here for you and the courses that you give. Any other question? If there's none, we'll give you half an hour back to your day.
Great. Thank you, everyone, for joining. A recording of this will be
There's
the Decentralized Trust YouTube channel later today.
There's a question
yes.
from Daniel. Daniel, can you
Yes.
like to answer it, Harsh?
Yeah. So question is, what are the system requirements for implementing the SDK? So currently we are focusing on the JavaScript and TypeScript stack. We have been for the normalization and centralization of all APIs and data structures. We have used TypeScript, and for packaging the SDK, we are obviously using npm. And then for the blockchain part, as long as the blockchain part is concerned, the smart contracts and all, we have been using Solidity and yeah, Solidity stack.
Hi, Harsh this side. So I'm one of the mentors for the project. So the system requirements for implementing the SDK for the end user side is basically would be like we are developing in such a way that if you are a non-technical or technical person, you can very easily like pick it up and use it because it will have a very end-to-end framework built into it. Like how you already like if you work with different LMSs, and if you try to handle their interfaces locally, that's what we are going for. So it would be very easy to have use these SDKs and like with minimal system requirements. Secondly, for Rust version of the SDK, uh, Rust is a good choice because it's good memory and it has good paradigms for what we are working for. Of the door. Secondly, the way the APIs and the function for the LMS is structured, JavaScript is want to work with Rust. We can eventually we can have a FFI for that FFI layer to be able to implement that. So yeah, but that's more of a long-term discussion.
Thank you, Harsh. Daniel has more questions. Would you have a Rust version of the SDK? Because this is a long-lived educational architecture. Rust is a good choice.
Rust is a great choice. Rust is a great choice. I'm working with Rust in other places, and it's being used heavily in a lot of open source projects. But we had already started working on this, like learning tokens. This has been going on for like 3 years, and the existing framework was in JavaScript. So shifting right now and refactoring the entire thing does not make sense when we should get the foot out of the door. You know, that should be the goal. Uh, the optimizations that come with Rust are very useful when we have a good scale. So yeah, that's again a long-term discussion. What different blockchain does the learning token system support? So it support Hyperledger Besu, and it's a private blockchain of its own where it will have HD wallets for each of the learners that would be interfacing with our system. Uh, Different blockchains in that sense. It's a private blockchain, so there is no question there. But we are hosting it on Callidio, which is again hosted on AWS, and it supports Ethereum, it supports Hyperledger Besu, and Fabric. So yeah.
And Besu is a hybrid blockchain, which has a private part for the institution's private data, and it has a public part. Okay. And so the learning
Daniel has another comment. Using Rust would allow you to create a singular SDK that supports multiple language. Yeah, so that's FFI layer, right? Foreign function interface layer. So you have, for example, you can use BindGen to build C bindings, and then you can have UniFFI for building out these bindings to other languages. But again, not all of them. So for UniFA, for example, which is one of the most used uh, uh, used uh, used platform for building these other bindings for other languages, which is supported by the Mozilla Foundation. That has good support for Kotlin, Swift, Python, but not others, not so much, because currently I'm working with it, and we are having to use a lot of third-party handlers to be able to work with, say, like React Native, JavaScript. So yeah, it's still in work. Like it currently is at 0.3 versioning. So yeah, but that's another discussion altogether, honestly, and that would require us to refactor what we built in the last mentorship. Yeah.
Well, thank you all for your time and for your interest. We hope to see you at the beginning of December for our final report of this mentorship. Thank you.
Thanks all.